Okay, this is college algebra, and we are on chapter 7, piecewise and power functions. This particular first lesson, we are going to talk about piecewise functions and how they relate to the real world. So we've got some real world applications here. We're just going to say apps of piecewise functions. It is possible that a data set cannot be represented or modeled with one equation. So we can use a piecewise defined function when there's not a single function that accurately represents the situation. A piecewise defined function is so named because it is defined with different pieces for different what should go there, parts of its domain rather than one equation. All right, so an example we've got here is postage. The postage paid for a first class letter jumps up by 20 cents for each ounce after the first ounce, but it does not increase until the weight increases by 1 ounce. So this table here gives the 2015 postage for letters up to 3.5 ounces. We're going to write a piecewise defined function that models the price of postage and graph this function. So the function that models the price P of postage for X ounces, so this is like our Y value, this is our X value, where X is between 0 and 3.5 is given by this piecewise defined function in 4 pieces. So it's 49 cents if the ounces are between 0 and 1, including 1, 70 cents if the ounces are between 1 and 2, including 2, 91 cents if the ounces are between 2 and 3, including 3, and $1.12 if the ounces are between 3 and 3.5. So here's the table that represents this piecewise defined function, and then here's the graph. So another name for this kind is called a step function, and that's so named because it literally looks like steps or a staircase going up. So you can see that in a situation like this, we do still have a function. In other words, it passes the vertical line test. At no point does my graph cross 2 points at the same time, because here we see we've got an open circle at the beginning of each step. So when we jump up, that point is not included, but everything past it is included. So it is a function. It's just not a smooth curve, and it's defined by 4 separate pieces of the domain.